today. But it actually created a very efficient process and one of the most dynamic designs ever, I believe. It's definitely something that's going to change the road landscape.
Hopefully you guys saw it down there and you experienced it. It's definitely real. Those are real trucks. We're on our way to build them. But what that stainless steel opportunity did for us, it has let us rethink the factory footprint. We don't stamp those. That's a huge part of it. We don't even paint them. So our footprint got smaller, and we started to think about innovative ways to take those constraints and make great products.
But that constraint didn't really change the end result of the truck. It's a super dynamic truck, and it has all the functionality you would expect out of any of the other competitive trucks. And the best thing about it, it's coming this year.
So ideally, after all that, we would design, engineer, manufacture, and plan for automation happening together. It gives us the opportunity to question requirements. This is something that is fundamentally only available at Tesla. In the places I used to work and the top manufacturing companies in the world, they don't sit together.
Yeah,
we are one team.
Nowhere I know has all these teams together thinking about these processes from the very beginning.
In fact, all of those engineering teams, manufacturing, design, automation, they're all in one org. They all report to one person. We can't point fingers at each other, so we have to solve them together, which is the best way to innovate. A traditional way of making a vehicle is this. You stamp it, you build a body in white, you paint it, and you do final assembly. And what's interesting is these shops are dictated by the organizational structures that exist, and they're dictated by the boundaries that exist in the factories that are laid out. If something goes wrong in final assembly, you block the whole line, and you end up with buffering in between. This is at the tail end of its manufacturing optimization. Henry Ford first invented this assembly line in 1922. It's been 100 years, and it's really hard to make a change after 100 years. And when you watch it happen, it's actually really silly to a guy like me. You take all these stamp panels, you put them together, then you put them in a framing station, you build a body that looks something like a car, you put the doors on, and then you paint them. Once you get the color, you take the doors off, and then you start putting the interior inside the car. It comes in through the openings that already exist. I wish it went in like this big piece like this, but there's actually people coming in and out of the car. There's awkward movements. Then we lift the car up. We put stuff from underneath it. We put it down. Then we put the seats in the car. And finally, we close it all out with glass, and we bring those doors that went away for a trip, and we put them back in the car. Most of the time, we're doing this with a big, giant car and moving it and doing really nothing to it at all.
What's funny, though, in this kind of whole process is that just recently, Toyota just called this an engineering work of art.
True.
The Model Y.
That was humbling, but at Tesla, it's not good enough. If we're going to scale the way we want to do, we have to rethink manufacturing again. As part of the master plan, we have to make another step change in cost. We started this on Model Y when we made these huge gigacastings, and we deleted hundreds of parts. We simplified assembly with the Model Y structural battery, where we decided the floor should be a part of the car. The battery is the floor. We put the seats and the interior on the battery, and we bring it up through a big open hole, and we assemble it. And this allowed us to do things in parallel, fully rethinking the process and reducing the final assembly line by about 10%. And we thought, maybe we could do this other places.
Yeah, I mean, in a way, the constraints become part of the solution rather than a problem.
So when you think about what I'm trying to say, I really want to hammer this home. When you have a car that's about 5 meters long, and you have people working around it like we did in Model 3, and we change that to this process where we take different parts of the car, and we can do more at the same time, like we did with the Model Y structural battery pack. What you see here is us doing that on the front part of the vehicle, or the rear part of the vehicle. That means we can get more people working on the car, or robots, working on it at the same time. That means we have better operator density, less time doing nothing. I call that space-time efficiency. It has nothing to do with quantum mechanics. We can have that conversation later. But we get 44% more operator density, which means more work, less time walking back to the station, 30% improvement in space-time efficiency. And because we're not building it in and out of the car with those slow movements of those robots I showed you from production